Good morning. We have some folks here. We're going to work on questions on chapter 5, chapter 6. First of all, I wanted to go over a few things. So the next test is only going to be over chapters 4 and 5. So I'm going to answer questions over 6 today because I want to kind of get you going. But next week, I'm going to put up the assignment today for the review, like what you should be reviewing for next week. And then I'm happy to schedule like a separate review if everybody wants, but there are going to be problems from the book again, so that you can check your answers so that, as you're working, you can check. But the test will be 2 parts, and I'll kind of even section them, like here's a chapter 4 stuff and here's a chapter 5 stuff, so it kind of helps you separate. My hope is that everyone will, if you want to take it before spring break, you can take it next week, but if you want to wait and review and take it after class or take it with me, during my office hours after spring break, the beginning, I don't mind at all. But there are going to be videos that are going to be due after spring break for that Thursday. So what is that, like the 14th maybe?
And what chapters are these? Is the test over?
The test is over 4 and 5.
Okay.
So yeah, so class will be on the 14th after spring break. So I will have chapter 7 stuff started for then. So you'll kind of be getting into chapter 6. The last test is only going to be over chapter 7. And I'm debating if we're going to do a last test or if I'm just going to do the majority of the final as chapter 7. That kind of gives us a little bit more time to work on chapter 7. So that's kind of what I'm leaning towards. I'm not going to assess over chapter 6 except for all the assignments that I'm doing. So it's not going to be on the exam. I want you to be exposed to it, but unless you're going on, if you're taking 151, you'll be exposed to more of that next semester and assessed over it then as well. So that's why we're kind of, working on it this week or whatnot. I've got some assignments on it, but the test that's going to be, we're going to review next Thursday in class before spring break. If anybody wants to stay and take it, they may. If you're like, I want to continue reviewing and make a really good note sheet, I really think it's valuable to get good at making a note sheet and the examples that are on your note sheet and the structure of your note sheet. And if you want to do that and take a break over spring break and then come back and take it, you may. I'm guessing the school is closed over spring break. I don't know. I'm kind of new to Glen Oaks as far as that goes, but I'm kind of thinking that. Okay, so also there were some questions on 6.1. So the assignment that I have for tonight, the idea of that assignment was getting you into the thinking of, as soon as you watch the video, attempting some problems. So I thought, let's watch the video and attempt 4 problems directly from the book. So they kind of look just like what we did in the video, so that you could just kind of see, like, am I able to immediately follow from the video? No, and that's okay. I'm going to address some things today so that you can maybe complete those today after the lesson. But that's the idea, is I want you to try things right after the video. So it's like, okay, I'm implementing what she just did. Can I make some connection from what she just did to this? And it's okay if you're like, I'm super fuzzy. That's what I want that assignment to be tonight, where it's just like, this is my initial idea of what is going on, and I'm going to give feedback. Is basically, like I said in the text, it's going to be graded based on completion, but I just am trying to give you immediate feedback, like, okay, these are the spots where you're getting, and this is where you're fuzzy, and that's okay. That's what it's supposed to be about. So let's just jump right into a few more problems for 6.1. That's where Danielle had asked originally. Back in here. Okay, so I'm going to share my screen. And you are all welcome to hop in and ask questions immediately as you have them. Okay, and everybody promises to do that. So first off, let's go to something that we hopefully are maybe comfortable with. So just so we're familiar with the symbols. So when we see this symbol, let's do one that you might not know. What does this, how do we read this symbol?
The square root of?
Okay, so the square root of 121, right? That's our number that we're looking at. So a backwards way of thinking of it is when we think of that squares, we're thinking, it's like, why do we think of square? Because we're thinking of some number multiplied by itself gets me to 121. And why is it the square? Well, when we don't see anything out here is the root, we assume it's a 2. So we're assuming this is a 2. Okay. So the 2 are instructions, just like when we talked about division last week in class, fractions, right? I said the denominator tells me the storyline of like what's going on with my fraction. This degree, this root out here tells me the storyline of what's going on with my root. Okay, it tells me that I'm looking for a pair of things. So it's kind of like playing Go Fish, or a game where you can have pairs or triples of things, right? Or fours of things. So I'm looking for 2 numbers that multiply to make 121. Now, most of us are probably familiar with this one. 2 numbers that multiply to make 100 is 10. And that's because 10 squared makes 100. So we know it's something bigger than 10, right? And then, so we can play some guesses. We could go to Desmos, but we're going to see that that square root of 121 is 11. And that is because 11 squared is 121. Is everybody with me so far on that? Okay, that's what our goal is. And we might not always know them. And hopefully you're going to become more familiar with some of them up through 20 as you're working through the semester. And they're also, there's a whole list of them on page 495 in your book. There's a table of square roots, of cube roots, and of fourth roots. Okay, so I'm going to go through a common cube root for a minute. So let's say we look at this one here, the cube root of 64. So this 3 says that I'm looking for 3 things. That's what I'm looking for, right? Something cubed that gets me to 64. That's what my goal is. Now, you might off to the side say, hey, I already know this, the square root of 64. There happens to be one of those. Not a lot of numbers have a perfect square root and a perfect cubed root, and actually a perfect fourth root too. Okay, but this is 8, right? And that's because 8 squared is 64. Okay, so it's all about getting down to the bare factors of 64. So I'm gonna do this all down. So I'm gonna say 64. I'm gonna get it down to its basics. So I do know that this is true. 8 times 8. I'm gonna do some factoring while we're at this because I think that will help some folks too. So 8 times 8 is not a group of 3, it's a group of 2, so it doesn't satisfy my cubed root, it satisfies my square root. So I'm going to try to break these down even further, and I do know that 2 times 4 makes 8, and that doesn't help me as far as a thing multiplied by itself 3 times, because that's a 2 and a 4. But I also know that 4 can be a 2 times 2, right? So these are we're down to my prime roots. And that means if this 8 factored into 2 times 2 times 2, then this 8 is going to factor into 2 times 2 times 2. Does everybody see that? So that's down to the very basics. Okay. So if I look at 64, I can write 64 as 2 times 2 times 2 times 2 times 2 times 2. Is everybody with me just so far on this? Okay, because these are some basic concepts that if you can get them, it's going to help you feel more efficient as we do other things. Okay, so the game that we're playing is groups of 3, right? We're looking for a cubed root, right where my pen is. That's what I'm saying. I want groups of 3. Do we have some groups of 3 in my prime factors of 64? Groups of size 3. So 1, 2, 3. There's a group. And look at 1, 2, 3. I have another group. right? So I have 2 cubed times 2 cubed makes 64. Okay, so I can also look at this as I can also look at this as 1, 2, 3, 4, 8 times 8. We can also look at this as 2 times 2 is 4 times 4. So if we circled the 2's, here's a 4, here's a 4, and here's a 4. So we can also look at that as 2 times, or 4 times 4 times 4 also makes a 64. So we had 2 of the 2 to the 3's, but the cubed root of 64 just once, is there just one number that multiplied by itself 3 times to get to 64? And because there's a 2 cubed and a 2 cubed, we know that we can make something else. So we can see that all of my prime 2's can actually be a 4 times a 4 times a 4. And that is a group of 3, which is 4 to the 3rd. Okay. So you're probably wondering, well, I'm still trying to figure out. So let's just leave it at this, the 4 to the 3rd. So we know the cubed root of 64 is 4. Okay. That one seems a little bit trickier just because 4 broke down even further into 2. So let's say we did a more simple one. So if we said the cubed root of 27 is some number when we multiply it by itself 3 times, we get 27. So again, I'm going to write my factors of 27. We probably know 9 times 3 is 27, but that's not the same number multiplied 3 times. But I can factor 9 into 3 times 3, and then we have that 3. So again, we look at our root, and the name of the game is groups of 3, right? And I can see that I have a group of 3 here. So I have one group of 3. One group of size 3, not just a number 3, but one group of size 3. And that one group of size 3 happens to be the value 3. Is everybody following so far? Just kind of the idea of what the roots are. So it's a game. We're going by the root here. Is everybody okay moving to some letters to try to see if we can do some letter work, or do you want to do another number? I'll let you all call the game.
I'm fine with moving to like some letters.
Danielle's ahead. Okay. So let's move to some letters. Let's do the cubed root of x to the 6. So I am looking for something when I cube it. We're going to say something cubed gets me to x to the 6, because I don't want to use x there now, right? Because x is my variable. So let's just look at factors of x to the 6. which is nice because there's just 6 X's, right? 1, 2, 3, 4, 5, 6. And what is the name of the game? What is my goal? You can put up fingers. What is my group size I'm going for? 3. Do I have some groups of 3? I do. So let's circle them. So there's one group of 3. There's another even group of 3, right? So I'm going to write in words so that we can get comfortable with it. We have 2 groups of size 3 of X. So that means that X squared is my 6th, it's my cubed root of X to the 6th. Okay, so I'm going to show you another way to write this. It's called a rational exponent. Rational meaning a fraction and my exponent. So I can write this as my power, my exponent on the X is my numerator in the fraction. And my root, the name of the game, is my denominator. Just like we did last week when we talked about fractions, that 3 tells me the group size. Right? Remember when we said I had candy to share with friends in class or whatnot. And so basically I have 6 pieces of candy to share with 3 friends. Everybody gets 2 pieces of candy exactly, right? Because 6 divided by 3 is 2. And that is what we came up with, was X squared. Everybody follow that one so far? I'm going to do another one. Let's do, want to do a crazy mixed up one, a somewhat crazy mixed up one. Okay, let's do a 4th root of X to the 7th. So I'm gonna kind of do it both ways. So hopefully you can start seeing the pattern. Notice how I did my factors of 6 of my X to the 6 up here. And I came up with 2 groups of size 3. And then over here, I wrote it as a rational exponent of 6 divided by 3 gave me 2. So there's going to be a pattern of writing it as a rational exponent and visualizing, because hopefully we get to the point where we don't have to write this out every time. We can visualize this thing, and so we can write this thing instead. Okay, so we're going to write our 7 X's, 1, 2, 3, 4, 5, 6, and 7. And I'm also going to write my rational exponent at the same time, 7 fourths. So the name of the game is groups of size, what? 4. Thanks, Danielle, playing my game. Okay, so 4, and we have one group of 4, right? Do we have another group of 4? Oh, we don't have quite enough to make another group, do we? Okay, so we have one group of size 4 with 3 left over. And if we take 7 fourths and divide it, now I don't need Desmos. I'm going to show you Desmos so that you all can feel confident using Desmos. No, I want a new one. This, okay. So 7 divided by 4, and it gives me the fraction, the decimal, right? But I'm gonna go click on the fraction. Oh, and it takes me back to there. Darn. Okay, so the 1 we know is a 1. So you could go down here and just say, okay, 0.75, what is that in fraction form by itself? And click on that fraction, it will tell you it's 3/4. So notice we have, let's go back to our paper. So we're going to write that fraction as 1 3/4. 7/4 is 1 3/4. So let's see if we can make the connection with the 1. The 1 is we had one full group. We circled, there were 4 x's, right? Okay, so we can write this as x to the 1. We'll put 1 there now. Remember, x to the 1 doesn't need to be written as 1, but we're going to do it just so we can see the connection of all the pieces. Everybody with me so far? Okay, the 3 is the 3 that we had left over. So that's what the remainder is called when we divide, right? And the 4 tells us our group size, just like it does in the root. So the 3 so when we write this, the radical, when there's leftovers, is they just have to go back in the radical. So we say, yep, we had x third left over, and we still have to denote what was the name of the game. Because if it's not a square root, we have to let the reader know that the name of the game is 4. And we don't really have any of those in 6.1. I think we do in 6.2.
So do we have to put the x before the x to the third square root of 4, like the first one?
Do we have to do this?
Yes.
Yep. That one, when we simplify this, you're telling me that, yes, I had one full group that came out of this, and that I had 3 remainders
Okay.
that didn't simplify. So for instance, if I had, let me do a numeral one. So
Well,
if I
real
said,
quick,
go ahead, hon.
so would your final answer then be x to the first power 4 square root x3? Like that'd be your final answer, that whole thing?
Yeah, this right here would be, it would say x
Okay.
times the 4th root of x to the 3rd. Want me to write it in words? Because that's a lot to say. This is x times the 4th root of x to the 3rd. I think many students are fearful of math because when you don't understand the language, it's like me when I went to France. It was horrible because I had no idea what I was saying. So I didn't want to participate in anything because I didn't know what I was saying, right? So I can see where if you're not confident with speaking the language of math, who wants to participate? But once you know the game and you can start speaking the language, it feels more comfortable to play. Is everybody with me on that one? Let's do a numeral one that kind of works out weird like this. So, and I know this isn't all directly the problems in 5.1, but hopefully it's kind of stretching your understanding a little bit so we can go back to some basic ones in 4.1 and feel comfortable. So let's say I gave you this. What's the name of the game?
2.
2s. So groups of 2. Okay. So ideally, I want a number multiplied by itself gets me to 24. But I can see quickly in Desmos. So if I'm in Desmos, I'm going to show you what it looks like on my calculator, but I can say the square root of 24, it's not an integer. Okay. But just like I did up here, I can write the factors of 24. So 24, I can think of this as 4 times 6 is mine. If 8 times 3 comes to mind, you write it however comes to mind for you. So 4 can be a 2 times 2, and then 6 can be a 2 times 3. So we said the name of the game is groups of two. So I only have one group of two. And that is of the number of two. So the square root of 24 can be 2 because this is written, 24 can be written as, let's not do that. I wanted to do it over here. 20 square root of 24 can be written as a square root of 4 times the square root of 6. This is more like in the 6.2 kind of lesson. And so we do know the square root of 4 is 2 because we saw that over here we have a group of 2. And the square root of 6 is not. It's irrational, we call it. It's not an integer square root. So we're going to leave it as a square root of 6. So just like up here we said this is x times the 4th root of x cubed. This is going to read 2 times the square root of 6. Everybody with me so far? Okay, so let's look at how about we look at number 24. 24 wasn't the ones. What ones did I assign? I have to look again. Were there 5, 42, no, 17 and 23. So 24 should be good. So 24 says the 5th root, is that right? 5th root of 32. 32, x to the 5th, y to the 10th. Okay. Okay. So kind of how I do these. The 5th root of 32, I'm going to write that all by itself because that we can do that in our calculator. I'm letting you use Desmos, right? So there's no reason why that one you can't do in Desmos. We'll go do that in a minute. The other pieces I'm going to write as the rational exponent. So x to the 5 over 5 and y to the 10 over 5. Does everybody see what I did? I just took my exponent and put it in a fraction with my group size of 5. So that we're going to go to Desmos. So x to the 5 over 5, well, that simplifies to 1. So that's just x. And then this y, 10 over 5 simplifies to 2. So this is y squared. The cool thing is if you can write this in the rational exponent form, you can go to Desmos, right? And do 5 divided by 5, it's a 1. 10 divided by 5, it's a 1 or a 2. So let's go to Desmos and do this 5th root of 32. So again, just like in the systems of equations, I said you should be able to go to Desmos and find out the answer and then try to show me by hand that you've learned how to do it. The same with these. There's no reason why you can't show me the rational exponent by using a system and then coming here and going, okay, 5 divided by 5. Yep, I thought it was 1. Okay, 10 divided by 5. Yep, I thought it was 2. You're just checking your work. And then the root, you're going to go down to the keyboard and you got to go to the functions. A square root they have, but a regular root, you need to go to the functions. I think it's all the way down. Yep, it's all the way down here at the bottom where it says nth root. Oops. There it is, nth root. And then in the root, I can put 5. And then I'm going to say, is there a fifth root of 32? And there is. It's 2. So my answer is 2x y squared. So I'm going to challenge you to number 26 while we're all together. Get my glasses on here. Blind as a bat. Fourth root. 81. A to the 24th, B to the 8th. Now, the old books, I'm gonna tell you one of those sob stories of when I was younger and I had to like come up with all this by myself, like Einstein. Literally, the books when I was taught algebra, my teachers never explained it with this fraction thing, which I think is genius. I came up with that on my own. There are books now that do it, so I'm not saying like I came up with something nobody else did, but I came up with a realization that, oh, it's just a fraction that I'm using. And to me, it makes it much easier just to write it in fraction form, and then I can simplify from there. Please tell me somebody out there likes that. Okay. So I'm going to separate these. The numerals I'm going to try to do in Desmos, unless you already know it. The fourth root of 81. And then a to the 24 over 4 and b to the 8 over 4. Okay. So anybody want to help me out here? What do we get? Is there a perfect fourth root of 81? Did you try it in Desmos?
I just put it in my regular calculator and got like a 0.075 blah blah blah. So I was like, I think if I open Desmos, it'll close me out of the Zoom meeting. So I don't.
Okay. What did you put in your regular thing, hon?
I just did 4 divided by 81.
Oh, because it's the fourth root of 81, remember? 4 divided by 81 is a division, but this is saying I want to come up with a number when I want to come up with a number.
Yeah, I don't know how to do
81.
I don't know how to do a square root on my phone, and I'm pretty sure if I go to Desmos, it'll close me out of the Zoom meeting.
So let's just see if I can get iPhone to do an X root. Just so, I mean, if students are using it, we might as well try to. I'm going to turn it this way, right? It gives me more options this way. Oh, geez. Did I turn that? Okay, there we go. So there it is. You see the one that says Y, X?
How'd you do that?
Well, it's an iPhone. All I know is if you turn it, is yours an iPhone?
Yeah, but it won't.
Okay, so turn it sideways and hold it there for a minute.
I think I have my like
Thing turned off.
Thing turned off. Not how to turn it
Okay,
on.
so let's, we got to help a girl out here. Is it this
Is
thing?
your screen locked?
Which one is it for a screen lock?
Is it like this? Is it locked?
Which button do I hit though?
Here, let me on.
Is it the lock one? I just unhit it. It was red.
Okay, and then try and turn it sideways now.
Okay. See if it'll.
You
Oh,
keep it
there we
up.
go. Thank
Okay,
you. Yeah. Thank you.
Yay. Maylene to this, she said today.
Thank you. Thank you.
You're welcome.
Okay, teamwork makes the dream work. That's what I say.
So
Now, see,
4.
mine's gonna be hesitant for just a minute. Okay, so I want to do the y, the y root of x. So when I click on that, oh yeah, I forgot. You gotta clear everything out. So on ones like this, you have to tell it the root first. So we would have to say 4 and then hit that y root and then do the inside of 81. Oh, no.
You got to do the 81 first and then
Oh,
hit the square root button. I think so.
the root and then
Yeah.
do 4.
Yeah.
Oh, okay. So you have to do the 81, what's in the X, and then hit
Yep.
that button and then do the Y, the root, which would be 4, and then you should get 3.
Yep, I got 3.
Yay.
Woohoo.
That is so exciting. Okay, so we know that this is 3. And then can we simplify the 24 over 4?
To 6.
Fabulous. So this is a to the 6. And what about the 8 over 4?
2.
Squared 2.
So this should be b squared. Okay, so this is what I say we do. I say we take just a quick break, and I'm going to let you try the 17 and 23 on your own. Those are the ones that I want you to do for tonight. Try them if you haven't, and then let's see if some of your questions have been answered.
What page is that on again?
Page 502.
Thank you.
You are welcome. Okay, so we're back and we're going to look at number 87 on page 503. I'm going to share my screen to Desmos actually, so that we can do it here. It says the number of units N of a finished product produced from L units of labor input and C units of capital input can be expressed as blank. Okay, so when we say units of labor, it might be like what they might call man hours. So our friend came and put a couple new doors at my home yesterday or the other day. So if they were here for 8 hours, I would say that that was 8 man hours or 8 units, right? That's what the labor was. Labor means like physical people or somebody doing something. Okay. And actually there were 3 guys here. So 3 times 8 would be 24 man hours is what I would call that. And then the N or the C was units of capital. When they say capital, they don't mean like the capital of Michigan is Lansing or the capital of the US is Washington, D.C. They mean capital, and it's usually money. So it might be dollars or billions of dollars or whatever is what they're talking about. So they're saying find the units of finished product, N, so we can use that formula, that use 625 units of labor. So L is going to be 625 and 256 units of capital. So C is going to be 256. So I'm going to go here and I'm going to put in 30. And then in place of L, I'm going to put a parenthesis because I want to show that multiplication. And I'm going to put 625 parentheses. And then I'm going to raise that to that 3/4. So you can either go down and do that in your menu in Desmos, or your shift and your 6 key lets you go to an exponent, shift and 6. And because my exponent is a fraction, I have to put that in parentheses or it won't do it correctly. So parentheses in my fraction here is 3 divided by 4. And notice that my 3/4 stayed in my exponent. And then I'm going to arrow right to go back down. And I'm going to put the C, the capital outlay, which is 256 in parentheses. And I'm going to put that in an exponent. And notice on this one, I'm going to show you how I did it incorrectly. If it's my exponent is 1/4 and I did 1 divided by, oh, it did this one correct. It doesn't usually, it did. Of course it did. It's like taking your car in, right? It never does the bad thing when you get to the automotive guy. So it looks like using 625 man hours or units of labor and 256 units of money, whatever that is, they can make 15,000 units of their part. part of their parts. So maybe it's like plastic covers for my calculator, right? Whatever it is. So that's everything how I did that. So for the ones I want you to do for tonight, 84 and 86, I want you to use Desmos. Get practice putting that in. So if you do it in Desmos, you might certainly could save it and upload that link along with handwritten stuff for what I said they were 17 and 23. And again, it's based on completion. I'm just there to give feedback. Okay. I should have been doing this earlier in the semester. Just doing a couple little things from the notes to give you feedback before you start working on the assignment, the real assignment. Okay. So where's everybody want to go? Are there any questions anybody wants to ask over any of the chapter 5 things? Just to throw it out there, I mentioned it earlier to those on the live call. And the 5.1 worksheet, I meant to not assign 8 through 12. And so I apologize profusely, or not 8, but 9 through 12. So I didn't count those against you. I do apologize. I left still the full number of points. So I really only graded it out of the first 8. And I'm finishing those up today. And then are there questions on 5.2 or 5.3? I'm happy to.
On 5.1, the 8 through 12, are they going to be on the test?
No,
Okay.
no. Anything I don't assess on the homework, I would never put on a test, but I'm glad that you asked that question, hon.
Okay, I feel like 5.1, I kind of understand most of it. 5.2, number 9, I was like, I have no idea.
Okay. Also, I thought, you know what, on 5.1, I do want to remind everyone some things about functions, because my 084 class, I have brought up some function things, but let me share my screen again. So number 7 and 8 are 2 different types of problems, but we're talking about functions. So functions are basically explaining like a machine and how a machine works. So in 7, it says this f of x. So this function is when I put in a value for x, I add it to 6, and then I divide by that same value, subtracting 3. So this f with 0 means that I'm using 0 as my input for x. I'm not multiplying 0 times anything. I'm putting it in for x. So I'm saying 0 plus 6 over 0 minus 3 becomes 6 divided by a negative 3 is a negative 2. Thought I would go through a couple of these so you can see. D means I'm putting in 3 for x. So this is going to be 3 plus 6 over 3 subtracting 3 is 9 divided by 0. And that is undefined, because whenever you have a 0 in the denominator, it's undefined. So that leads me to number 8, because number 8 is asking for the domain. The domain is what are the allowed inputs, right? What am I allowed to put into this machine without getting an undefined value like we did in D? So that means I can put anything into my function except for something that is going to give me an error, right? And an error in these would be when my denominator equals 0. So the only thing is my denominator, so x minus 1 on part A cannot equal 0, right? Because that's my denominator. And the only thing that would make that equal to 0 is a 1. So x cannot equal a 1. So I know some of you, if you went and like Googled it or whatever, I mean, I can kind of tell when some answers come out as like a Googled answer because they're way too correct. So the correct Google answer, or the correct answer for a real somebody working in algebra, would be to say a negative infinity up to 1 union 1 to a positive infinity. So I'm just going to have this openness here at 1 because it can't equal 1. It can get really close to 1, and then it'll skip over and go beyond 1.
Yeah, that's exactly what I got for A.
Pardon me?
That's what I got for A.
Good. And so B, and we did the intervals, right? That's how we showed it, were those negative infinities. So that's great if you're catching on to that. But if you also just said X cannot equal 1, I would have accepted that. I want you to start making connections like that's just not allowed. I'm worrying about the notation later. So in number 2, again, we cannot have our denominator. So X plus 2 cannot equal 0. So if I solve for X, I find out that X cannot equal a -2, right? If I put a -2, I'm going to get an undefined value for B. So that would be my answer. But you could also do a negative infinity up to a -2 union with a -2 to a positive infinity.
Yep.
Any questions so far? Okay, and then the last one is a little bit trickier because it's where can X squared minus 1, it cannot equal 0, right? So X squared minus 1 cannot equal 0. So if I'm trying to solve for X, X squared cannot equal 1. So you could take the square root of X, both sides, but also you could maybe see this factoring thing that we did in chapter 5. So X squared minus 1 is really X minus 1, X plus 1. And those multiplied together cannot equal 0. That would cause an undefined fraction. So that means that X cannot equal 1 or X cannot equal a -1. Those are my 2 issues. And so you could have a negative infinity up to a -1 union. Then you can have between a -1 and 1 union 1 up to a positive infinity. So there's kind of 2 breaks in that one. I thought that'd be a good time to go over those so everybody can see that we're kind of tying in the ideas of functions. Okay, now I had some folks that had some questions over 5.2 and 5.3. Is that right, Danielle? Or
Yeah, number 9 on 5.2.
okay, number 9 and 5.2 on the function on our worksheet.
Yes, please.
Okay, let's just write it on a separate sheet of paper. So if you're like, wow, I'm really filling up the paper, it's okay to use a separate sheet so that Mrs. Main can see your work. Please do. Okay, so number 9, let's just rewrite this. It's XA plus XB minus YA minus YB. And I'm glad it's a multiplication because we don't have to do any flipping, right? XA plus XB plus YA plus YB. Okay.
Mrs. Main,
Uh-huh.
could I get going?
Oh, yeah.
Because I don't have any more questions about it. I think I'm all good.
You're good. We'll see
Okay, thank you.
next week in class.
Okay.
Bye, hon. Okay, so we have 4 terms. So we're going to have to use the grouping method. So I'm just going to group them. There, you could group in different ways if you see things that match, but I just try to grab the first 2 and the last 2 on each because it's just easier that way. So on the top left, I'm looking for what they have in common. And so what do you see that these 2 have in common?
X.
So we have X, if we factor that out, we have an A plus B. So The idea is ideally that we'll have an a plus b left over here too, right? For the grouping method. So what do the second two terms have in common? That if I factor them out, I give an a plus b.
Y.
So if I factor out a positive y, I'm going to have a negative a minus b. So let's factor out a negative y. So if the negative comes out, then I'll have the positive a plus b left over. Are you with me on
Wait,
that?
what happened there? How did you get a negative y?
Because you see, I have minus ya
Or-
minus yb.
Oh, okay.
And I could factor out just a positive y, but then I'm left with a negative a minus b. And remember, with a grouping, we want these two things that I'm pointing at with my fingers, we want those two things to be the same.
Right.
So on the left, I would have had a plus b, and on the right, I would have had a minus b, and they're not the same thing. So I had to factor out the negative.
Okay. Makes sense.
So I'm going to just do an arrow, and I'm going to do my final factoring on that top left piece. And that means I really have an a plus b times an x minus y. Right? An a plus b and an x minus y. So now the top right, what do we have in common there?
X.
And then what do we have left over?
A plus 2.
Okay. And then what about here?
Y. Negative Y.
Did I write that correctly, or did I miss a subtraction on number 9?
Oh, it's supposed to be an equal sign, I think, actually.
Yeah, it says an equal sign.
Oh, I think that's supposed to be a plus.
Yeah, that's confusing. I was so
I
confused.
think we're gonna just go authority, and I'm gonna give you a plus on that. Oh, yeah, I think that was a typo. Oh, that was weird. I think so. So that's just gonna be a plus y comes out, and then we'll have an a plus 2 left. So for my final factoring for that down below is going to be an a plus 2 times an x plus y. Is everybody good with that so far?
Mhm.
That was weird. Okay, so the bottom left, what do they have in common?
X.
Okay. And then what do we have left over?
A plus 2.
Okay, an a plus 2. And then we have what left? What what in common here?
Y. A plus 2.
Okay. So that's good. They have the same thing left over. So that final factoring is an a plus 2 times an x plus y. So we have the bottom right to factor now is all. Okay, so they have an x in common, right? And we have an a plus b, and then a y in common and an a plus b. So its final factoring is an a plus b x plus y. So then we can start canceling top to bottom, right? So I can see they both have an a plus 2 and an x plus y and an a plus b. So they're left with an x minus y over x plus y.
Yep. That's what I got.
Yep.
Good job. That's like the toughest of the tough. So yes, this is definitely 5.2, 5.1, 5.2, 5.3 are definitely challenging your factoring skills.
So, I plan on taking my test next Thursday after class, if that's okay with you. But I wanted to ask you what you think for like my one page I get to make notes on, what I should, like what my main points I should focus on putting on there are.
Yep. So I would suggest, well, let's just kind of write down some ideas right now for note sheet ideas for chapter 4 and chapter 5. So chapter 4, I would, chapter 4 is all about systems of equations, right? So 4.1, I would, you can solve a system by graphing. So that's going to be Desmos. So I would be confident with putting things into Desmos and finding your intersection there. And then the addition and substitution methods. I would probably have examples of both on your note sheet. I haven't decided if I'm going to expect you to do one or the other in particular, or if I'm just going to say use either strategy, but you'd have to show work. I would also have on your note sheet possible results, right? So one possible result is a solution. So an XY solution. Another possible result is when you might get 0 equals and -2, which is not a true statement. They don't actually equal. So that means they're inconsistent or parallel. And then the third thing that could come out is a completely true statement, like 5 equals 5. And that's like, okay, that feels weird, right? Or a 0 equals 0. So a true statement where you haven't solved for anything, but you get a true statement is going to be dependent lines, where they're actually the same line. But it's going to be called a dependent system. And then essentially for 4.2, it's going to be the same thing, right? Except for it's just X, Y, and Z. So I would have examples. And I would probably have examples of both addition and substitution. For like a good example, maybe one that you could follow along with from like that we did in the notes or from the worksheets that we did of addition that you were like, oh yes, this is how I can do this. And then maybe one with substitution that you could follow along. So a good example for yourself that you could go back to, like spelling out the strategies of what we did. And then 4.3, I would have maybe examples of the different types of how to set them up. So if we go back to chapter 4, I've already graded everybody's chapter 4, so I'd like to kind of go back to 4.3 and maybe just spend a minute if everybody's okay and just kind of walk with you how you would maybe come up with these. So in 4.3, so where it says a number is one less than twice another, their sum is 14. So in 084 class, not everybody's in that class of mine, but 084, I said, come up with the 2 equations. That's the key. So the first one I would come up with is their sum is 14. So I have 2 numbers that they add to make 14, right? So an x plus a y equals 14. That's equation 1. We'll call that row 1. And then the other one is one number is 1 less than, so it's less than something else. It's less than 2 times the other. So I could say that y is 2x minus 1. So for me, for this one, I would use substitution. Because we already know how to make y. So this was on your worksheet number 1. Then question number 2 were the ticket problem. And so on that one, I'm just kind of throwing out how I would set up each of these. So this will kind of help you go back to these worksheets. So in this one, there's usually a count formula and a value formula. A count row and a value row. So on number 2 from worksheet 4.3, it said there were 750 tickets sold for a basketball game. And the total amount was 1,090. If adult tickets cost $2 and children's tickets cost $1, how many of each were sold? So I have A's and C's, adult tickets and children's tickets, right? So the count row would be my A tickets plus my C tickets. I know there are 750 of them. Right? Then my value row is, well, my adult tickets were $2 each. So 2 times my number of adult tickets plus $1 times the number of my children's tickets gave me $1,090. Number 3 is similar to that as far as the investment goes. I'll just give you the setup too. So number 3 setup was I had money that added to 12,000. So it was X plus Y is equal to $12,000. And then the interest earned was the value, the $790. And to find the interest, it was 6% on one of the investments. So I have to multiply by 0.06 and the other was 7%. So 0.07 on the other.
Miss Main,
Uh-huh.
I'm good on these.
Okay.
All right, I'll turn the work in for today.
Okay, sounds good. We'll see you
All right,
next
see
week.
ya.
Bye, dear.
See ya.
And then I'm going to start number 4, and then we'll move on to some strategies for chapter 5. Things for your notes. Is this helping? Is this what you're looking for, Danielle? Like things that you might put
Yeah,
on?
I want to know like what to make on my note sheet. So
Yeah.
really.
So then 14, just real quick on 14, because this one's a little bit trickier. So not 14, but number 4. So number 4 says how much 30% alcohol solution and 70% alcohol solution would be mixed to get 16 gallons at 60%. So I have X plus Y gallons, which equals the 16 gallons. And then one of them, we'll say the X is the 30%. So 30% of the X plus 70% of the Y. And then this one, you actually have to figure out that the percentage at the end is going to be a 60% of the 16 gallons. So this one, the interest one, you already knew your amount of interest, so you didn't have to do anything with that calculation, but this one you do. So those are your 2 equations on those. Then Let's go over some ideas for chapter 5 on the exam. Chapter 5 strategy or notes. Note sheet chapter 5. I'm going to let you use your factoring flow chart, so you do not need to kind of recreate that. Okay, but you're going to definitely, and knowing how to use your factoring flow chart is going to make or break your chapter 5 for everybody involved. I'm just letting everybody know that. So I would have some maybe examples of factoring. Example, and I'm just not going to rewrite the examples. I'm going to just say examples of factoring, examples of reducing, or we also call it simplifying. Rational expressions. I'll give an example. So x squared minus 25 over x squared minus 10x plus 25. Okay, so how would you simplify that kind of thing? I would have examples of multiplying and dividing. So that was the 5.2, right? And then I would also, for 5.1, I would also have examples of finding the domain. So that was from 5.1. And then the big thing from 5.2 is multiplying and dividing. So again, that's going to really go back to the factoring, understanding of your factoring. And then the 5.3 was adding and subtracting, getting the LCD. So and getting the LCD. Anything else you can think of?
No, I think that's pretty much it.
Awesome. Okay, well, let me know if you need help with anything.
Okay. All right. Well, have a good rest of the day.
You too. Bye, dear.